Our planet, Earth, is a wonderfully active place. It might seem solid and still beneath our feet, but it is not. Deep below the ground we walk on, the Earth is made of enormous pieces of rock, rather like a giant jigsaw puzzle. These pieces are called tectonic plates, and they are always moving, although incredibly slowly. They float on a layer of hot, soft rock, much like a raft on a slow-moving river. Most of the time, we do not feel this movement at all because it is so gradual and so gentle. It is a constant, silent dance happening far beneath the surface, shaping the very continents and oceans over millions of years. An earthquake is what happens when these giant plates get stuck. Imagine trying to push two very heavy, rough stones past each other. For a while, they will not move. All the energy you are using to push them builds up and up. The same thing happens with the Earth's tectonic plates. They press against each other, and the edges get caught. A tremendous amount of pressure begins to build along the line where they meet, which we call a fault line. This stored energy is immense, waiting for something to give way, like a tightly wound spring holding a powerful force inside of it. Suddenly, the pressure becomes too great for the rocks to hold. With a powerful jolt, the plates slip and move past one another. All that stored energy is released in an instant. This release sends out huge waves of energy, called seismic waves, in all directions. These waves travel through the Earth's layers, just like ripples spreading across a pond when you throw a stone into it. It is this sudden, violent release of energy that we feel on the surface as the ground shaking. The place underground where the earthquake starts is called the hypocenter, and the point directly above it on the surface is the epicenter. The shaking can be very small, a little tremor that we barely notice, or it can be incredibly strong, powerful enough to make buildings sway and roads crack. A powerful earthquake can change the landscape in just a few moments. It reminds us that the ground we think of as solid is actually part of a dynamic and ever-changing system. These events are a natural part of our planet's life cycle. They are not evil or kind, they are simply the result of immense geological forces at work, a process that has been happening for billions of years and has helped create the world we know. Now let us consider what happens when one of these powerful earthquakes occurs not under the land, but under the vast ocean. The floor of the sea is not flat, it has mountains and valleys just like the land. And just like on land, the tectonic plates are constantly moving beneath the ocean water. When an earthquake happens there, the seafloor can be pushed up or down with incredible force. A huge section of the ocean bed, perhaps many kilometers wide, can suddenly lift or drop by several meters. This abrupt movement acts like a gigantic paddle pushing the water. This sudden vertical movement displaces an enormous volume of water above it. Imagine dropping a very large stone into a bathtub. It pushes the water out of the way, creating waves that spread out. An undersea earthquake does something similar, but on a scale that is almost impossible to imagine. It shifts a colossal column of water from the seafloor all the way to the surface. This creates a series of powerful waves that begin to travel across the ocean. In the deep ocean, these waves might be quite small at the surface, perhaps less than a meter high, and they can travel as fast as a jet airplane. These waves are called a tsunami. The word comes from the Japanese language, where su means harbor and nami means wave. This is a very fitting name, as these waves show their true power when they reach the shallow waters near the coast. As the tsunami wave travels across the deep, open ocean, it carries a tremendous amount of energy. Ships in the deep sea might not even notice a tsunami passing underneath them because the wave is so long and spread out. But all that energy is racing towards the land, a silent and fast-moving threat that is gathering its strength for its arrival. The danger begins as the wave approaches the shore. The depth of the ocean becomes shallower near the coast. This change in depth causes the fast-moving wave to slow down. As it slows, all the energy it was carrying gets compressed. The front of the wave slows, but the back of the wave catches up. This forces the water to pile up, and the height of the wave grows dramatically. A wave that was barely noticeable in the deep ocean can transform into a towering wall of water, many meters high, as it prepares to crash onto the land with devastating force. Let us imagine a quiet village by the sea. The sun is shining and people are enjoying a peaceful day on the beach. Suddenly, they notice something strange. The ocean seems to be pulling back from the shore, much further than it ever does during low tide. The water recedes, exposing the seabed, with fish flapping on the wet sand. This unusual sight is a natural warning sign that a tsunami is approaching. It is the trough of the enormous wave arriving first, drawing the coastal water out to sea to feed the massive crest that is following close behind it. For those who do not understand this warning, it can be a moment of curiosity, but for those who know, it is a sign to run to higher ground immediately. A few minutes later, the horizon darkens. A line appears in the distance, growing larger and larger. It is not a normal breaking wave, it is a rising wall of water, churning with incredible power. This is the crest of the tsunami wave, a fast-moving surge that does not stop at the shoreline. It carries the full force of the undersea earthquake with it, ready to inundate the land. The wave crashes onto the shore with unimaginable force. It is not just one wave, but often a series of waves that can arrive minutes or even hours apart. The water rushes inland, moving much faster than a person can run. It sweeps away everything in its path: houses, cars, trees, and bridges. The sheer weight and speed of the water act like a liquid bulldozer, destroying structures that have stood for years in a matter of seconds. The surge can travel for many kilometers inland, flooding entire towns and changing the shape of the coastline forever. It is a truly awesome and terrifying display of nature's power. After the first wave passes, the danger is not over. The water that surged inland must flow back to the sea, and this outward flow can be just as destructive. It drags debris and wreckage with it, creating a dangerous and chaotic current. Then, another wave from the tsunami series might arrive. The people in our imaginary village, if they reached high ground, can only watch as the place they called home is overwhelmed by the sea. It is a powerful reminder of how vulnerable coastal communities can be to events that begin hundreds of kilometers away, deep beneath the ocean waves. Understanding the science behind earthquakes and tsunamis is not just an interesting subject, it is critically important for saving lives. These are not malicious acts of nature, they are the results of geological processes that are fundamental to our living planet. By studying how tectonic plates move and where fault lines are located, scientists can identify which areas are most at risk of earthquakes. This knowledge allows us to build stronger, more flexible buildings and bridges that can withstand the shaking, protecting the people inside. It is through understanding that we can prepare. For tsunamis, this understanding is even more vital. We now have a global network of sensors called the Tsunami Warning System. These sensors are buoys in the ocean that can detect the pressure changes caused by a tsunami wave passing overhead. When an undersea earthquake is detected, scientists can quickly calculate if a tsunami has been generated and predict which coastlines it will reach and when. This information allows authorities to issue warnings, giving people in coastal areas precious time to evacuate to safer, higher ground. This system has already saved countless lives. Education is our most powerful tool for survival. It is essential that people, especially children living in at-risk regions, are taught what to do when an earthquake strikes. They need to know to drop, cover, and hold on. They also need to learn the natural warning signs of a tsunami, such as the ground shaking or the sea suddenly receding. When people are aware of the dangers and know the evacuation routes, they are far more likely to survive. This knowledge empowers communities to protect themselves and to act calmly and quickly when a disaster occurs, turning fear into life-saving action. Our planet will always be a place of immense power and change. Earthquakes will continue to shake the ground, and tsunamis will occasionally be born from the depths of the sea. We cannot stop these magnificent natural events. However, by continuing to study them, by listening to the earth, and by preparing our communities, we can learn to live more safely alongside them. Respecting the power of nature and understanding its processes is the key to protecting our future. It allows us to appreciate the wonder of our dynamic world while taking the necessary steps to safeguard human life.